4c says at t equals 0, the height of water is 5 feet. So that's our initial condition of t equals 0 and the height is 5 feet. So let's use separation of variables to find an expression for h in terms of t. So we're going to then start with our differential equation. dh by dt is equal to negative root h over 10. Okay, and then we're going to separate the t's with the t's and the h's with the h's. In this case there's no t, but we're going to put the dh and the root h over here, and then we're going to end up with negative 1 over 10 dt. Okay, once we've separated the variables, we can integrate both sides. And integrating this is power negative 1/2. So if we increase the power by 1, we get power 1/2. Okay, and then we're going to divide by 2. So we end up with 2. So we're going to divide by positive 1/2. So we end up with 2. On this side, we're going to end up with negative 1 over 10t. And don't forget the plus c. Okay, so the initial condition then allows us to solve for the plus c. I'm going to solve for the plus c as is here. So I'm going to plug in h is 5 and t is equal to 0. So this term is going to become 0 plus c. So that makes c easy to solve for. C is equal to 2 root 5. So taking this equation here, I'm going to then solve for h. So I end up with negative 1 over 10t plus 2 root 5. Okay, I'm going to divide both sides by 2. So we get root h is equal to, I'm going to move this to root 5 minus t over 20. And then squaring both sides of this, we're going to end up with our h of t function. Okay, so h as a function of t is equal to square root 5 minus t over 20 all squared. Okay, get that there. Not too sure what that is. Okay, but there's our equation.